Hi, good afternoon, guys. Today we'll be covering DNS, and I'll be explaining you regarding DNS, its workflow, and all the terminologies associated with it. Let's begin. And I assume everyone among us knows like why do we need DNS. If anyone would like, he can explain. So anyone can take the initiative. Hello, Ankit.
Okay, so DNS is used to find out IP address against a domain name, vice versa. When we search any domain name on a browser, so the DNS server find out the IP associated with the domain name.
Oh, good. So what DNS does is, let's say it's like a phone book. Uh, so earlier we used to have a phone book where, let's say, my friend Ankit, he has a mobile number, let's say 1234, and my other friend Gaurav, let's say, he has number 8972. So it will be very difficult for me to remember all these numbers associated with the name. So what DNS does is it will remember all the numbers. You just have to know the name. So you have to give the name to the DNS server. It will give you the number for that. So it makes it easier for the human mind to remember all this information, and he doesn't have to worry about the numbers. So that's how DNS works. And instead of the name, we use host names in the DNS. So let's say www.google.com. So, and instead of the numbers, it remembers the IP address for that host name. So let's say 8.8.8.8. It's the DNS server IP for the Google DNS. Okay. So that is the requirement of the DNS in the modern world. So we have known what is the definition of the DNS. Now, how DNS actually works. So let's say you are a end user on your machine. So you need to reach to the Amazon.com. Okay. So you know the name or the uh, website name. So it is www.amazon.com. Okay. So, but on the internet, we need an IP address to reach to the destination. And this Amazon.com is also associated with an IP address. So what our user machine will do, as soon as you type www.amazon.com in your browser, let's say it's Chrome, so first it will check its browser cache. So this is your browser window. You type amazon.com in the URL bar. So it will check its browser cache. What is cache? It's a temporary memory in the inbuilt in the browser or in your machine. So it will store, let's say in the past you have visited Amazon.com and you already have the IP address for Amazon.com. So it will remember that IP for a certain period of time before its time to live expired or its validity expired. So let's say you are visiting Amazon.com for the first time and you don't have it in your cache. So what it will do, and let's say you are connected to Wi-Fi of your home network. So what it will do, it will reach out to the DNS server or local DNS server of your ISP. Okay. Now let's say this local DNS doesn't have the IP address for Amazon.com. So what this local DNS will do on behalf of you, it will reach out to the root server. So there are three kinds of hierarchy, or you can say zones, in the DNS namespace. First is root, second is TLD, which is top level domain, third is authoritative name service. Okay, so it will reach out to the root server. What root server will give to the local DNS server? The ed. So root server will say, so what is root server? How we denote the root server? It's a dot in the end. Okay, let's say it's www.amazon.com, and the dot in the end is the root server. Okay, so what this root server will say? Okay, I don't know the Amazon, the www.amazon.com, but I know where you can find the .com. Okay, so which is stored in the TLD. So it will give the IP of a top level domain server to the local DNS server. This local DNS will reach out to the TLD. In TLD, we have different types of TLDs. Okay, first is generic TLD. Okay, then there is country TLDs, and then there is ARPA. So what generic TLDs hold? So it holds let's say .com, .edu. Okay, like those. The country TLDs will hold the information about, let's say, .in, which is for India, .us, which is for USA, .uk, which is for England. Okay, and the ARPA is used for the reverse DNS lookup, which is if you try to resolve an IP address for a host name. So you know what is the IP address, but you don't know which host name is associated with it. Okay, so it will. So your root server will give you the IP of TLD, which is for .com in our case. Now this .com will tell the local DNS that, okay, I don't know the actual IP of Amazon.com, but I know where you can find the Amazon namespace. Okay, so it will give you the IP for Amazon name servers, which is authoritative name servers. Wait, I'll remove this thing. Okay, so it will give you the IP of the Amazon's authoritative server, which is uh, so what is an authoritative server? So this is an server which maintains everything associated with the Amazon domain. Okay, so if you reach out to the authoritative server and ask what is the IP for www.amazon.com, it will give you the IP address. As soon as the local DNS will receive the IP address, it will give it to your machine. Now your machine will initiate an connection request over TCP or UDP, whatever is required, to the Amazon server. So it will now reach out to the Amazon. Okay. Now you see the Amazon page. So all this process is done in the backend. Okay. Anyone has any doubt so far, or any terminology which you don't understand?
You name all the that generic server, and what were the rest two ones? ARPA generic, and uh,
Country,
what was the other one? Okay,
country. Okay.
okay, thank you.
So this is the workflow of the your general DNS resolution. Okay. So what we call this resolution? So when our machine reached out to the local DNS, Okay, and then our local DNS reached out to the root, then it reached out to the TLD, then it reached out to the authoritative name server. Okay, what this is called? This process is called DNS query. So there are two types of DNS queries. One is uh, recursive and one is iterative. Okay, so now we'll know about the types of queries. So first will be your recursive query. So everything we studied just previous to this, which was our machine will reach out to the local DNS. Okay, our local DNS will reach out to the root. Then the root will give the IP of TLD to the local DNS. It will reach out to the TLD, and then TLD will give the IP of the authoritative name server. So in this recursive query, everything is performed by the local DNS server. So client machine doesn't know that the DNS server is performing all these uh, tasks at the back end. So for the client thinks the IP is provided to me by the local DNS server, and the local DNS server has the information about, in our case, Amazon.com. So this is called the recursive query, and our local DNS server will be called the recursive resolver. Okay. This is the recursive query. Okay, so I'll not remove this. It will be easier for you. Now, what is iterative? Okay, so in the recursive query, every task is performed by the local DNS, but in the iterative query, the task is performed by your local machine. Okay, so let's say it reached out to the local DNS. Okay, the local DNS says, okay, I don't know the IP address for Amazon.com. You please reach out to the root server. It goes to the root. Now the same task is performed. Root gives the IP for TLD, then it gives the IP of the authoritative name server. So you see the difference over here, guys.
Yes.
So now you know what is the iterative query and recursive query, right? Guys, speak up, please.
Yes, we got to know the difference between the recursive and the iterative.
Anyone has any doubt?
Okay, can you repeat the iterative one? Iterative
So
query?
yeah, first you should know what is a recursive query. Okay, so if you understand this, it will be very easy for you to understand the iterative one. So in the recursive one, everything is performed by your local DNS server. But in the iterative query, your local DNS server says, okay, I don't know the IP address of the Amazon.com. So you yourself please reach out to the root server. This is the IP of the root. It might give you some idea where is Amazon.com. So all the task is heavily performed by the client machine, but in the recursive query, everything is performed by the local DNS. Understood? Anyone has any other doubt? Please speak up now.
No, sir.
So all these queries are initiated on UDP, but it's never the case that all the queries will be resolved on the UDP. Sometimes the DNS uses TCP also, and we'll cover it in the later part of the video. Okay. So now we understood the queries and the workflow of the DNS. Now we'll move on to the zones. So what is a zone? Does anyone know what is a zone? Yes, no.
No. We
No,
are
sir.
aware of the zone.
What?
DNS zone is transferring the records to the different primary server.
That is a zone transfer. But what is a zone itself?
I don't know. Can you tell it?
Mm, Anyone else would like to try? Okay. So what is a zone? It's basically a zone file. So let's say what is the hierarchy of DNS? So it starts with the root, okay, which is denoted by dot. Then it has the TLDs, which are generic, and your country, then R. Okay. Then comes the your authoritative name server. So it can give you the Amazon.com, Google.com, or you can say Rajasthan University.edu. This is an education website. Then this can give you the country level domains like Amazon.in, Amazon.us, Nike.uk. Okay. So everything is a separate zone. This is a separate zone. So this whole thing is called a namespace. Okay. In this there are different zones. So this root is a different zone. This generic TLDs is a different zone. Country is a different zone. Inside this generic .com is different. .uk is different. Sorry. .edu is different. In this .in is different zone. .uk is different zone. This Amazon.com is a different zone. So any part of the namespace which is maintained or managed by an entity is called a zone. So in the case of Amazon, this Amazon domain is managed by Amazon. Okay. So this is a separate zone and managed by the Amazon. Any doubt?
No, sir.
Yeah. So how these zones are maintained? These zones are maintained with the help of zone files. So these are stored in the server which contains all the types of record. So what is the types of record? Like the most common ones which are stored in the zone files. First is the SOA record, which is the primary one. Then there are NS records, which is name server. Like it will have the information about the name server, which will resolve the IPs for the host name. And there are A records, which will give the IPv4. Then there are quad A records, which will give you the IPv6 for a domain name. Then there are C name records, which will give you the host name for an host name. So it won't resolve the host name into an IP address, but it will give you some other host name. Then you have to resolve that host name to get in the IP. So this is used in the cases of uh, CDNs or proxies which are used in modern world. So I'll explain this to you later. And then there are MX records, and which are for the mail exchange. It holds all the IP addresses for the mail servers responsible to forward the email. Then there are TXT records. So it stores the text data which is used for the verification purpose in the services like SPF or any other. So whenever you raise a request for the certificate, so you want to create a certificate for a domain or your website, then the CA will validate your domain with the help of this TXT record. Okay. So any questions in the record types, guys?
Yeah, actually, why
Can
do
you
we use this
tell me about
MS record?
S SOA? SOA.
This MX record.
Yeah, yes. Jay asking about SOA, and I asked about MS records. Could you please
Yeah, yeah.
explain both more?
So okay, so first we'll start with the SOA record. So SOA record stands for start of authority. So you might get a hint with this name, authority, which is associated with authoritative name server. So what SOA specifies that it's the first record in the zone file, and it will indicate that this is the start of the zone file. So whenever you reach out to the, let's say you are on the route, and then you go to the TLD. So in the TLD, first record will be the SOA record served, and it will, or let's say you go to TLD, it gives you the IP address for the Amazon name server. Whenever you reach to the Amazon.com or Amazon name server, it will give you the SOA record that this is the start of authority. That this means that this domain or this namespace is managed by this organization. Okay, and these SOA records are used during zone transfer. Okay, now come to the MX record. Uh, so MX records hold information about the mail exchange server. So whenever you send an email, you should know the IP address of the server which is responsible to forward your email. So this will give you the MX record. So whenever you try to resolve an let's say you are sending the email from gmail.com, then you want to resolve the MX or the mail server for the Gmail, it will give you the MX record in the DNS response. Okay. Any other questions? Gaurav, Jay.
It's yeah, clear.
Okay. Anyone else have any other questions? Hmm?
No, no, sir.
So moving forward, so we have known what is the DNS flow, types of queries, then zones, DNS hierarchy, and the types of records. Right? Now we will study about the zone transfer. Okay. So wait. So what is a zone transfer? So let's say we are in the namespace of Amazon. Okay. So there are different name servers in the Amazon domain. So there will be multiple servers. Okay. But let's say this is the primary server. So all the added things, or let's say Amazon has launched another service. So in our case, let's say video, which is Prime Video. Okay. So let's say they have launched this service and they want to update the records for this uh, video domain. So every change will be made in the primary server. No changes can be made in the secondary server. These are secondary servers. ठीक? So let's say you have made the changes in the, or let's say you are configuring the name server for the first time. This primary server was empty. There was nothing. You have uploaded or updated the records in this server, and the records will be stored in the zone file. Okay. Now you you can't make any uh, writing changes on the secondary server. So the secondary server is dependent on the primary server to receive all the information which is stored regarding the records. So what it need to transfer the zone file. So the zone file transfer is called the zone transfer. Now the zone transfer is of two types. Okay, AXFR, which is full zone transfer. Then there is IXFR, which is incremental zone. So full zone transfer you can understand by its name, which is you are transferring the full zone file to the secondary server. But in IXFR,
In
hmm,
and
yeah,
in increment zone transfer, it only transfer the update. It only happen.
yes, yes. So what what is incremental zone transfer is? Let's say I was explaining, let's say Amazon.com is already present on the primary server, and you have added the video records in the uh, primary server. Now the video information is not available to the secondary servers, and you can't write them on the secondary server. So secondary servers need to get the uh, the updated information to their zone file. So instead of transferring the whole zone file, it will just transfer this portion of the zone file which stores the new information. Okay, so this is called the incremental zone transfer. Understood?
Then the last point
What?
in this incremental. Could you repeat the last point?
This incremental zone transfer.
Yes, yes.
Okay. So let's say an example. Okay. So let's say you have a shop. Okay, and you will have all the information about the stock in your shop. Okay. What are the goods stored in the shop? And you have to send it to your uh, inventory manager. Okay. So let's say he has all the information about the existing stock in the shop. But now you have received new stock or new items in your shop and you have added to your inventory. Okay. So this is new item.
Okay.
Okay. Now it will be easier for you. Let's say this is the full stocks inventory is of 1000 pages. Okay. So it would be easier for you to send the whole 1000 pages to your stock manager, which already have the 900 pages. Okay. Or it is easier for you to send 100 pages. 100, right? So what it will do? So your stock manager will know, okay, okay. So everything which I'm receiving is the new information. I'll add it. It becomes 1000 pages. Okay. So instead, if you are sending 1000 pages for the new stocks also, he has to go through everything and compare, and then he will add this 100 pages, and it is very time consuming effort. So instead of this, we are sending only the updated information. So this is basically the
So,
incremental zone transfer.
like, basically, if we send the 100 pages,
Mm-hmm.
then it will be EXFR. And if
IXFR.
we send only, so,
So it's
sorry,
clear with the name incremental.
mhm,
Okay, which is any information which
1000 pages will be uh, AXFR,
yes.
and if we send only 100, uh, 100 pages,
Mm-hmm.
then it will be like
Yeah.
AXFR,
So
incremental zone.
yeah,
Okay,
incremental
okay,
is the any new information which has
mhm,
been added to the database. Okay.
okay,
So
okay,
only
understood.
the
Thank you
new
so much.
information will be shared with the secondary.
Mhm.
Okay. So now here comes the question: how the secondary server will know? Okay, I have to initiate the zone transfer, and there is a new information added on the primary server. Does anyone has any idea how it will know? Okay, the information has been added to the primary server. Anyone? Guys?
No, sir.
Okay. So I'll explain it to you. I mentioned the SOA record, right? That these will be used in the zone transfer. So what happens is that the SOA records have a serial number. So uh, let's say in our case it is 123. Okay, and this SOA information has been shared with the secondary server. Now it has stored this information in its database. and let's say now the new records has been added to the primary DNS server, so this serial number will also be updated. So now this time it's 213, let's say. So the second with the like in periodically the secondary server will check with the primary server the status of the server. So the primary server will share the SOA record. The secondary server will compare it with the older record. So initially it was 123. Now the updated or the new SOA record has the serial number of 213. So now the secondary server will know, okay, there has been update to the primary server. It will initiate IXFR, and the new information will be shared to the secondary server. Got it?
Yes.
Understood?
Yes.
Okay. So can anyone explain or tell me, so DNS works on which protocol?
UDP.
Is it
Both
always
both TCP and UDP. Both
so?
TCP and UDP.
So when it will use the TCP? Because
TCP
mostly I've
for
seen it works
for
on UDP. Hmm?
TCP for maintaining the connection, establishing the connection.
No, but why it needs the TCP? The information can be transferred on the UDP, right?
Yeah, yeah.
Right? So I'll explain it to you. There is a So what happens? There is a limitation to the DNS, which is it cannot transfer um, DNS response, which is uh, more than 512 bytes. Okay. So let's say the DNS response is more than 512 bytes. What the so I'll explain to you with an example. This is the DNS server. So your client has requested for an IP address or any other DNS information, and the response is greater than 512. Okay. So what the DNS server will do? There is a flag in the DNS response. So I'll request everyone to go through the DNS request and response headers after the session. So there is a flag in the uh, DNS response truncated. So whenever the requested amount or the file or the response is greater than 512 bytes, this truncated flag will be set or will be enabled in the response. So now the client knows, okay, so what does this truncated flag mean? That the response is greater than the 512 bytes and cannot be sent in a single packet. Okay, it cannot be sent in a single packet. So to to ensure that we receive all the response in multiple packets, we need to initiate a TCP connect. So when the client sees that the truncated flag is enabled in the response, it initiates a TCP connection to the DNS server for the same query. Now the DNS server sends the response in multiple packets, and also the zone transfer is done on TCP. because the zone file is very big in size. Okay. So if anyone asks you when the TCP is used, this should be your risk. Few things to know regarding the size limitation of the DNS. So earlier it was 512 bytes. Still it is 512 bytes, but there is a term called eDNS which gives the capability to transfer up to 4096 bytes on UDP. Okay, but this is not supported by all the machines or all the servers. So eDNS negotiation is also a part. If eDNS is not supported on the server, you have to work with 512 bytes and you have to switch to the TCP. Okay. So I'll request you to go through few of the things after the session, which is the request and response. You can make a note of this, and the eDNS, just the basic understanding, and DDNS, which is dynamic DNS. This is the extended DNS. Okay. Anyone has any questions, guys?
No, sir.
Anything else
Yeah,
we
good.
studied so far? Any question? We'll hold for 10 seconds. If I don't see any response, I believe everything is clear with you guys. Okay then. So I'll take it as a no. No one has any other questions. I think we are good to go. So see you guys soon again in next session with another topic. Right. Have a good day. Bye.
Thank you so much. Thank you so much. Thank you.
Bye.
Bye.
Thank you, sir.